Welcome to a lesson with Dr. Powell. Let's take a look at tangent inverse of x and its derivative. I'll write out its derivative right here, 1 over 1 plus x squared. Let's think about how the standard part of tangent inverse, so just one period long, that's 1 to 1, so it has an inverse, looks like this. And for cotangent inverse of x, its standard, this is tangent x before you take its inverse function. For cotangent, before you take its inverse function, it actually looks like this. Again, it's a horizontal reflection of this guy. So you should expect a similar thing to happen as happened between sine inverse and cosine inverse in their derivatives. We should expect to have something like -1 over 1 plus x squared, which is exactly what happens. So if you can do one, you can do the other. It's just going to be the reflection here, and it just has to do with restrictions. A similar thing happens actually between secant and cosecant. So it really suffices just to consider kind of rationale for just one of them. All right. Okay, so let's think about what tangent inverse is. It's a function that goes from ratio to angle. So let's think about a right triangle with an angle, and that angle represents the output of tangent inverse. So the input x is going to be a ratio, which is going to represent tangent, right? So the tangent of this angle is going to be x over 1. So this setup would work nicely. Now what goes right here is 1 plus x squared. So let's see, that is equal to tangent of theta. Now, if we work out the details, this guy right here is actually equal to secant theta. You can get that by an identity, or yeah, even if you wanted to, just multiply all the sides of this by cosine, and you'll end up getting cosine sine and 1 here, which is what you would expect with the normal cosine sine 1 triangle. They're very related. So anyways, this is secant. So what does that tell you right here? Well, the derivative of tangent is secant squared. So it's actually just with that drop the square root, right? But you're taking the reciprocal of that, which as we were looking at before. So hence, this is a non-rigorous, but just an intuitive, quick rationale for what the derivative of tangent inverse is and cotangent inverse. Thanks for watching.